Here we are taking a further look into our warm-up. Now we know that with any function, and our last function was y is equal to x squared plus 1, that we can always go ahead and throw in particular points and see what they come out to be. In fact, let's just go ahead and prove our target point. So our target point that we kept seeing and approaching from the warm-up was 1, 2. So if you throw in 1 here, let's just say we don't know that y is 2. If we throw 1 in for x, we end up with 1 squared is 1, plus 1 gives us 2. And so we end up then with this point 1, 2. Now, if we recall back to algebra, and how you can find the slope between any points is always going to be y2 minus y1 over x2 minus x1. So that never really changes, even if we're looking for the secant of those 2 points. So we still have y2 minus y1 over x2 minus x1. And we saw that with various different scenarios. Now, as a result, because we're looking specifically to getting towards this target point, we can go ahead and substitute that in for one of these x1, y1s or x2, y2. So for our slope, then for the secant, it should just come out to be some y2 minus our particular y values for our target point, 2, over our particular x value for that point that we've just kind of chosen that's near 1, 2, minus our target point's x value, 1. Alright, and so that's pretty much how we can just find the slope for any secant. And that's why we're right now just letting this be x2, y2. But again, now we're getting closer to that target point, which is why we're going to subtract it by that target point. So now we're curious, what would the slope be if our x value that we selected was incredibly close to our target point's x value? Well, first of all, we have to find out what is the corresponding y value to first then be able to plug it in for our slope for the secant. So first of all, we have to find out what is our y value for this particular 1.001. So we end up with y is equal to 1.0001 squared plus 1. And then taking the calculator out, we end up with 1.0001 squared. This is our corresponding y value that we get. 1.002, 1.0002, 0001. So again, we end up with 1.0002, 0001. But then we also have to add 1 to that. So as a result, our y value comes out to be 2.000200001. Now that we have our other point, really it's 1.0001, comma 2.00020001, we can go ahead and find the slope between our target point and this point that's incredibly close. So when we do that, we end up with, again, our slope that is secant still, of 2.00020001 minus 2 all over 1.0001 minus 1. And so it looks like our slope for this secant comes out to be 0.00020001 all over 1 minus this, or I'm sorry, 1.0001 minus 1 just comes out to be 0.0001. And then just dividing that we end up with 2.0001. So pretty much close to 2. Now, if we were to imagine that this variable h is some distance away from our x value. So in other words, when we were looking at our target point, in fact, let's see if we can zoom in a little bit more than that. So when we're getting close to this target point, then there's some distance that we are in terms of our x value away from that. And we're going to call this distance h, depending on whatever x value we want, and it's going to also give us some y value. So again, here would just be some x value. We'll call him x2, y2 that we kept, finding and trying. But that x has some distance from our target point. Well, if it's some distance from our target point, then this particular x would be 1, because again, that's our target point. It's 1, comma 2. So our distance would be, for this point, 1 plus whatever h is, and that would give us our x2. For our y2, all it is pretty much taking this x and throwing it into the function. Because again, that's how you can actually find your y values. Taking the x, finding out what the y is. And as a result, our y2 just represents f of 1 plus h. In other words, when we took this particular x value, where it's this distance away from 1 plus that 1, and threw them into the function, and then we end up with our y value. So we can even then see that when we tried this point that was incredibly close to that target point 1, the h value was just pretty much what we added to that 1. In this case, it would have been 0.0001. And that's when we plugged it into the function right here, we ended up with that y value. Now, this has to work for any h value, though it's our goal, as you can tell, that h is getting incredibly small. So for example, when we were looking at our first warm-up, this h value, see how it went from 1 to 4? I'm sorry, 1 to 3 rather? That h value would have been 2 units away. Whereas in our second one, when we graphed him, that distance, that h value would have only been 1. Whereas the third one, so again, it went from 2, 1, and now something pretty small, a lot smaller. And then from our warm-up continued, we saw it get really small, very, very close to 1. And so it's really our hope that that h approaches the value 0. Because when h gets to 0, that's when we actually get our tangent slope for that particular line. So again, though, that is the warm-up continued from our 2.1 notes.